Good afternoon, everyone. Am I audible? Let me know, is my voice clear? Am I audible? Let me know, is my voice clear? Am I audible? Okay, so right. So today we will be learning powers of a number, also called laws of indices. This is a topic that is common for both MCA and MBA syllabus. Whatever we have learned so far, all are common for both MBA and MCA. But this topic, it is going to come as MCA topic. Okay. For those who are going to write MCA exams, this will be an MCA topic. You might get 2-mark questions also from this one. For those who are taking up MBA exam, for them, this comes as your numerical quantitative aptitude or under reasoning section, you're going to get questions from this topic. So today's topic, as we discussed, as you have seen already, it is powers of a number, also called laws of indices. Laws of indices. So what is an index? What is an index? Index is a power number. It's power of a number. That's why I have given both the names in the thumbnail. I've mentioned powers of numbers. I've also mentioned loss of indices. So index is basically power of a number. So under loss of index topic for PGCET MCA students, this comes under max topic where they implement many formulas to solve the questions. And they'll also be getting a 2-mark questions from this topic. For MBA students, it won't be considered as loss of indices. You will be solving it. You will be solving questions based on remainder theorem and powers of a number. These two we will discuss today. But the concept or the backbone of both these topics is same. So that is why we have combined both the type of questions in today's class. So what is an index? It is power of a number. So suppose you are writing a power m. Okay, a power m. Here, this a is called the base. And this m is called as the power or index. Both are same. Indices is a plural of index. Okay, so here when we have any number of this format, if you might have also heard the word surds, right? Surds, many of you would have heard the word surds. So what is surds? These are numbers with fractional powers. So numbers with fractional powers are surds. So you don't have to learn it as a separate topic. Surds means numbers with fractional powers. Square root, cube root. Numbers with fractional powers. Whatever loss of indices we are learning here, those indices are applicable for surds also. You don't have to learn it as a separate chapter. See, if you are taking up something like JEE main syllabus, there you will have very advanced questions where you will have to learn surds itself as a separate topic. Now, all these things, whether you see the topic as loss of indices or powers of a number or surds or even remainder theorems, All these things come under this same topic heading. Okay. Now here you have seen what is base and what is index. How do we multiply them? So let us see certain examples. So some examples related to this topic we'll see. So suppose you are multiplying a number 5 times. Okay, you're taking a number 2, you're multiplying it 5 times. 1, 2, 3, 4 and 5. So this is written as 2 power 5, which is 32. So what does 2 power 5 means? It means you are multiplying 2 5 times, which gives you 32, right? So suppose you are multiplying this 5 times and dividing it by 2 3 times. Then basically this 3 2's will get cancelled and you will be left out only with 2 square, which is 4. Now, if I have to write it in the form of index numbers, then this numerator, it is nothing but 2 power 5, right? Numerator is 2 power 5, means 2 I have multiplied 5 times. Denominator I have multiplied 2 3 times. Now this is equal to 2 power 5 minus 3, which gives you 2 square 4. So basically, if I have a number like this, instead of expanding and then cancelling, we are going to use loss of indices and you will get the answer. So we will learn this type of indices here. So first write down the rules, the loss of indices. So the first rule is a power m into a power n is equal to a power m plus n. So what does it mean? If you have two numbers, in both the numbers, base is same. Okay, base is same, powers are different and you're multiplying them. Then you need to add the powers for the answer. So here, base must be same. If you have observed, I have written a as the base for both these numbers. Base must be same. And a power m divided by a power n is a power m minus n. So if you are having division or if you're having a fraction in which a number has same base but different powers, then you can take a number from denominator to numerator, or you can take a number from numerator to denominator. The one that shifts its position, its power, you have to change the sign. So a power m minus n is there, or you can also write it as, basically you're taking a power n to the numerator, n becomes minus n. You can also write it as 1 by a power n minus m. So n you're writing here, m you're bringing it to the denominator. Here it is plus m, so it becomes minus m here. So taking, basically what is this division? You are taking a number to the numerator, or you're taking a number from numerator to the denominator. Whichever number is in its original position, for that we will not change the sign. The other number which we change the position. Okay, in this case, I'm shifting this number which is in the denominator to the numerator. So n becomes minus n. If I'm shifting the other way, that is numerator, if I'm bringing it down to the denominator, then m becomes minus m. Remember, here in the options, definitely they would have given minus in the answer. Okay, and many students get confused. Sign changes only for the power, not for the number. If the number is a negative number, answer will remain negative depending on whether the power is even or odd. So here, whether the answer is even or odd depends on what are the signs of the numbers. But when you're shifting this, we are changing only sign of the power, not for the base. Okay, this is the other rule. So you can write it like this, equals to 1 by a power n minus m. So here also base is same. Suppose you have a power m into b power m. So here bases are different, but power is same, right? So you can write it as a into b whole power m. And if you have a power m divided by b power m, you can write a by b whole power m. So in these two cases, index is same. Okay, if the index is same, you can combine the bases. If the base is same, you're combining the index. Hope this is clear. If the base is same, if you're multiplying, then you will add the powers. If you're dividing, you will subtract the powers. If the power is same, then whatever is the base, whether it is multiplication or division, you're writing it without power, and basically you're writing a whole power. Vice versa, like a into b whole power m, if you have, you can also split the powers as a power m into b power m. Now here, the common confusion or the common mistakes that the students do is, if they have a power m plus b power m, they will write it as a plus b whole power m. This is wrong. When you are adding two numbers using addition or subtraction, okay, so here you are adding two numbers. Suppose you are multiplying two numbers. If you are combining two index numbers using addition or subtraction, you cannot apply this formula. You can combine the bases and write the whole power only for multiplication and division. Keep this in mind. Here also in the numerator, you have only a power m by a power n, then you can write it as a power m minus n. Suppose you have a power m plus 2, a power n minus 5. So if you are having other numbers also, then you cannot. And if that other numbers are in this addition or subtraction, then you cannot. But if you have multiplication, then you can. Suppose you have into b power n into c power x, something like this, then these two you can combine because they have same base. This and this you can't combine because they neither have same base nor they have same power. Bases are different, powers are also different, so you cannot combine them and write it as one single number. Hope this is clear. Let us solve some questions, then you will understand why you cannot combine like this. The next rule in loss of index, please write down these loss of indices. The next rule under loss of index is, if you have a power m whole power n, means a power m to the power n, multiple powers, then a power m to the power n, then if you have power to the power, so here basically this power is for this one, okay, in this case you can just multiply and write a power m into n. We'll see examples for all these indices and we'll see some problems based on this. Then you will understand it much better. Hope you have copied all this. If not, you can take a screenshot now. I'm showing all the 5 rules in one screen. Now, these are loss of indices, means if you have numbers involving powers, then these are the rules that you will use to simplify them. We'll solve few questions based on this for you to understand. See, I have a simple question here. 1 by x cube is equal to x square into x power k. Also, you can write one more rule here. That is, if you have a power n, you can write it as 1 by a power minus n, or 1 by a power n can be written as a power minus n. You don't have to write this separately. It is same as the second rule, wherein one number, if you're shifting from numerator to denominator or vice versa, you have to change the sign of the power. So same thing is applied there. Okay. Now here 1 by x cube is equal to x square into x power k. Find the value of k. Here we will write it on both the sides. We will make sure that the base is same. So 1 by x cube can be written as, we have different ways of solving it. So let me give first solution is, left hand side is 1 by x cube. I will write it as x power minus 3. Now here I have x square into x power k. I will use this for this rule. First rule, a power m into a power n, base is same. and we are multiplying it. So we need to add the powers, right? So I will use that. So this is going to be x power 2 into x power k, which is x power 2 plus k. Now in both the sides, base is same. So we can equate the powers. So which implies minus 3 is equal to 2 plus k. So what is k? 2 goes to LHS. It becomes minus 2. Minus 3 minus 2 is minus 5. So if you have some number on both the sides and if the base is same, you can equate the powers, or if the powers are same, you can equate the base. Now we'll see the next question. Here we have two variables. Let us solve this one. 8y power 6 divided by 2y square minus 2y square into y square. Now, this type of questions where you have x, y, such variables, this type of questions will appear only for MCA students. Okay. Wherever you have such variables, this will appear only for MCA students. For MBA students, they will not get variables like this, but there will be values. So method of simplification is same for both of them. Now here we'll write this. This is 8y power 6 divided by 2y square minus 2y square into y square. Now here 8 by 2 is 4. Y power 6 by y power 2 is y power 4. 6 minus 2. Okay, so y power 4 minus, this is 4 into y square is again y power 4, because base is same, we need to add the powers. Base is y, add the powers, 2 plus 2 is 4, so you get y power 4. So both the numbers are same and you're subtracting them, the answer will be 0. Hope it is clear. Give me the answer for this one, or let me solve this because it has negative numbers, and then I'll give you the next question to solve. See here, minus 2 b power minus 4 whole power minus 2 divided by b square. Always have a order in which you are going to simplify this. Now first simplify this one. I have given you the last rule here, right? Fourth rule, I think. Yeah, fifth rule. A power m to the power n is a power m into a power m into n. So here we have this number whole power minus 2. So we will include it for both of these numbers. Okay. So this is, you will get, you can solve it again in multiple ways. So I will give you the first solution. First solution is, first let us, 2y into y is not 2y, it is 2y square. Okay. 2y square into y square, it is 2 into 1 is, okay, sorry. Yeah, right. So this is 2. Y square into y square is y power 4. Correct. 4y power 4 minus 2y power 4 is 2y power 4 is the answer. Correct. Thanks for that. Okay. So here, first solution, what we do is, I'll first simplify this power and then we'll divide. Now minus 2 power minus 2. B power minus 4 into minus 2. Minus 4 into minus 2 is plus 8 divided by b square. Now, this number, whenever you have a negative power for a numerical value, first shift it to the other side of the denominator. Otherwise, it will be confusing. Okay. Shift it to the other side of the denominator and make the negative power as positive power. So here you're going to get minus 2 whole power plus 2. Understand? I'm shifting this number from numerator to denominator. I changed the sign of power only, not for the number. Number, you should not change sign. Only for the power, you have to change the sign. So minus 2 becomes plus 2. Now this is b power. Here smaller number is there, no? To take that to the the other side. So 8 minus 2. So this is b power 6 divided by minus 2 square is 4. This is one way of solving. Another way is first removing all the negative powers. So what you can do is this negative power, I'll first make it positive power by writing it in the denominator. So 1 by minus 2b power minus 4 whole power 2. Now you have to first multiply this divided by b square. Now multiply this power 2 to both of these numbers. So you get minus 2 square b power minus 8. Now in the next step, divided by b square is 1 by b square, right? Into 1 by b square. Now this minus 8, you can take it to the numerator and write it as, this is 4. So this is b power plus 8. This 2 goes to the numerator, which is b power 6 by 4. Now, depending on the options, you will have to choose the answer. Now, the options might have not been given as b power 6 by 4. Instead, they could have given it as 2b cube whole square. They could have given like this also. Okay, because now, yeah, so this is going to be 2 power minus 1 here, minus 3, minus 2. Like this, they could have given. If they give like this, 2 power minus 2 is 1 by 2 square, which is 1 by 4. And then minus 3 into minus 2 will be plus 6. So b power 6. Or they could have given 2 power minus 1 b cube power 2. So they could have given the options in various ways. Based on whatever is given, you find out, once you simplify, see which of the options is equal to this, and then you can get which is the answer. So these are the rules that we have learned. So the first rule that we have learned is a power m into a power n equals to a power m plus n. This is the first rule that we have learned. Second rule, this I have given as a fifth point. A power m to the power n is a power m into n. Then third rule, this is, I have given this as a second point there. A power m divided by a power n is a power m minus n. And any power, any number raised to power 0 is 1, which we have not written here. If you want to write it down, any number power 0 is 1. And any number power 1 is itself, which I'm sure all of you know. This I have given. So any number which is there in one side of the fraction, you can take it to the other side by changing the sign of the power. Now let us solve some more questions. So that was the whole numbers, right? Power of the whole numbers. Now I told you about surds, that is fractional powers. So if I have a square number, that is, if I have, so what is surds? Fractional powers, I have already told you. So suppose a square is equal to b. Okay, if a square is equal to b, then square root of b will be equal to a, right? So if 4 square is 16, then I'll write square root of 16 as 4. We can write plus or minus 4, but square root of 16 is 4. What is the square root of 16? It's nothing but 16 power 1 by 2. That is 4. If you write cube root is nothing but power 1 by 3. So square root is any number power 1 by 2. So I can write square root of x as x power 1 by 2. Cube root of x can be written as x power 1 by 3. So if you have numbers with such roots, then first convert it to an index number and then simplify like your index number problems that we have done so far. Or you can even understand it this way. If you are shifting the power to the other side, just like you have a into 5 into a is equal to 25. Now 5, if you're shifting to the other side, here it is in multiplication, it goes to the other side and it goes to the division, right? It becomes the denominator. Similar to that, here if it is new whole number, if it's a integer power, it goes to the other side and it becomes fractional power. So 4 square equals to 16 can be written as 4 is equal to 16 power half. Power 2 going to the other side becomes 1 by 2. Okay. Similarly, one more example. If you have 3 cube is equal to 27, this 3 goes to the other side, it becomes 1 by 3. Okay. Suppose you have 8 by 8 by 125. This can be written as 5 2 cube by 5 cube, right? 2 cube by 5 cube. And if you want to shift the powers to the other side, then 8 by 125. This here you will write power 1 by 3. So 2 by 5 whole cube is nothing but 2 by 5. 2 cube by 5 cube is 2 by 5 whole cube. This can be written as this. We will shift the power to the other side. For the whole number, it becomes 1 by 3 power, which is nothing but the cube root. And in the right hand side, we have 2 by 5. This is shifting powers from one side to another. So in one side, if you have a whole number, to the other side, it becomes the fractional power. Similarly, one side, if you have fractional power, in the other side, it becomes the whole number. For some number, if you have the number like this, that is square root of x is equal to 25. It means what is square root of x? It is x power half is 25. This half goes to the other side and it becomes square. So x is equal to 25 square, which is 625. Hope this is clear now. This one here, what we have done is square root or cube root. If it is there, we have written it as a fractional power and we have shifted to the other side where it becomes the whole number. The power becomes the whole number. Okay. Suppose you have a number where you have a fractional power also, whole number also. Say for example, if you have square root of x cube, understand this clearly, square root of x cube. How do we write this? This square root is x cube, I'll write as it is. Square root is nothing but power half, right? Whole number power half. For this x cube, we are taking half power. Now we will use this fifth rule. What was our fifth rule? If a number has a power, which again has one more power, then we are going to multiply these two powers. Okay, a power m to the power n or a power m whole power n, both are same, is equal to a power m into n. Okay, so that way if I write here, it is going to be 3 into 1 by 2, which is x power 3 by 2. Now this taken to the other side, suppose x power 3 by 2 is equal to, I'm just writing some number randomly. Let me take 2 cube is 8, 27, 4 cube is 64. Yeah. So 8. I will write like this. Okay. X power 3 by 2 is equal to 8. Suppose if I have a question like this, which is square root of x cube is 8, find x. Now how to simplify? First, simplify all these powers using the loss of indexes that we have so far discussed. First, remove this root, which is called as the surd, right? The square root or cube root. First, rewrite it as a fractional power. So for x cube, we will write square root is half power. Now I am using that fifth rule, which is if I have 2 or 3 powers, I need to multiply all the powers. So it is x power 3 into half, which is 3 by 2 equals to 8. Now I am going to use this rule wherein I can shift power from left hand side to right hand side or vice versa, where if you have a whole number, it becomes a fraction and vice versa. Okay. Now here, what do I have? 3 by 2. This goes to the other side. It becomes 2 by 3. Is this clear? It goes to the other side and becomes power 3 by 2 in the left hand side, goes to the right hand side and it becomes 2 by 3. Now, what does this mean? Now, again, we'll split this. 8, 2 by 3. I'll write 2 into 1 by 3. So basically, it is 8 square. For this, I need to take cube root. So what is 8 square? 64. For this, if I take cube root, we will get 4. 4 is the answer, not 2. Cube root of 8 is 2, but then we are squaring it. You can also, instead of this, you can also write 8 power 1 by 3 into 2. So first take cube root, then square it. That is also fine. 8 cube is 2. then you square it, you will get 4. Both are same. So when you're splitting the numbers, the order in which you apply doesn't matter. When you're splitting numbers in the power. Has everybody understood this? Any questions? Is it clear, guys? Yes or no? Right. So here we have certain questions. I'll send this in your WhatsApp group. You can practice them. Only one student is responding, others are not responding. It would be great if you can answer so that we will know if you have understood or not. If there is any doubt, if any question that you have not understood properly, we can try to explain it. So let me quickly solve these things. Just observe. We have 4 power minus 5 by 2. First, let us remove the negative power. So it becomes 1 by 4 power 5 by 2. Okay. So we cannot reverse the power. Okay. If we have to reverse like 5 by 2, if I have to write it as 2 by 5, I need to take it to the right hand side or vice versa from right hand side to left hand side. Here I'm just removing the negative power for which I will take from numerator to denominator. So 4 power minus 5 by 2 becomes 4 power plus 5 by 2. Now this power, I will split it. I'll split it as 4 power half whole power 5. I can also write it as 4 power 5 whole power half. 5 by 2, I'm just splitting it as 5 into 1 by 2. I can write it as 4 power 5 whole power half or 4 power half whole power 5. Both are equal. But which one do I choose? I know square root of 4, right? Instead of multiplying 4 5 times, then taking square root of that, because 4 power 5 is going to be a big number and you need to know square root of that. Instead of that, take the simple number first. First, take the fractional power so that the number becomes small. Like what we did here. Instead of 8 square and then cube root, first find out cube root of 8. Cube root of 8 is just 2. Now 2 square or 2 power 4 is easy to find, right? So here what we do, instead of applying power 5 first, we'll apply power half. So we are going to get 4 power half is nothing but square root of 4, which is 2. 2 power 5 is 32. 1 by 32 is the answer. Okay. Now the next question. 125 power 2 by 3. So here the power is positive. So there is no need to shift it from numerator to denominator. Now let us just split this power. 125 power 2 by 3. Like I told you earlier, which one are we going to apply first? We'll first apply the fractional power to reduce the number, right? So I will write 1 by 3 whole power 2. So 2 by 3, we will be writing as 2 into 1 by 3. I am first applying fractional power. So 125 cube root is 5. 5 into 5 into 5 is 125, right? 5 cube is 125. So 125 cube root is 5 and 5 square is 25. Okay, next. 8 power minus 2 by 3. Just like our first example. First, let me shift it to the denominator. I think this number we have already taken. 8 power 1 by 3 and then square. So cube root of 8 is 2, 2 square is 4. So this is how you simplify numbers with fractional power or the negative power or positive power, anything. And the questions that you actually get will not be like this. You will have 2-3 different numbers. You'll have to multiply and find out what is the final answer, where most of the numbers gets cancelled and you'll get a small number. Like here we cancelled it, right? In this one, this got cancelled. So like that, it will get cancelled and you'll get a small number. This is about loss of indices, how we are going to apply it for solving questions. So the next one is powers of a number. which is a very important type of question for MBA students. This will also occur for MCA students, but it's a very commonly repeated question for MBA question paper. So what is that powers of a number? Here, it is more of observation and guessing. Okay. In this powers of a number, we need to identify the pattern of last digits usually for every number when we increase its power. So basically here, the type of question that you will get is find the last digit or find the unit digit. Unit digit is nothing but the digit in the units place, which is the last digit. Find last digit in the product of or in the sum of. This is a kind of questions that you will get here in powers of numbers. So here you have to first have a proper observation. Understand this clearly. Any number, when you keep on multiplying it, the answers will have a pattern. Especially the last digit will have a cyclic pattern. Now let us look at it with examples. So I'll take number 1. 1 square is 1, 1 cube is 1, right? All numbers, 1 power 4 is 1. So 1 power any number is 1, isn't it? Now let us consider 2. Okay, so for 1 power anything. 1 power anything is 1 only. So 1 power n is 1. Next, if I take number 2. Now what is 2 power 1? It is 2. 2 square is 4. 2 cube is 8. 2 power 4 is 16. Okay. Now what is 2 power 5? 2 power 5 is 32. So I am going to get the same last digit now. See, we are talking about only the last digit. So this ended with 2. Here also it is ending with 2. Now 2 power 6 is 64. 2 power 7 is 128 and 2 power 8 is 256. So if you observe, here we have 4, here the last digit is 4. Here it is 8, here the last digit is 8. Here 6, here the last digit is 6. Now this pattern is going to repeat. So this is a cyclic pattern which is going to keep on repeating for powers of 2. Now you can check 2 power 9 is 512 where last digit is 2. 2 power 10 is 1024, last digit is 4. So basically last digit is repeating. How it is, so how many different last digits you have here? 4 different last digits and it is repeating in the order. So you have 4 different last digits, right? 4 different last digits are available and they are repeating in this order. So the first one is 2, then 4, then 8, then 6. Again 2486, 2486. In this order, it's going to repeat. Now let us take number 3. For 3, we will write like this. 3 power 1 is 3. 3 power 2 is 9. 3 power 3 is 27 and 3 power 4 is 81. Now I will not write the next 5 numbers. I'll write only one. 3 power 5 is 243. So as soon as you get one of the previous last digits, you can stop writing further because since the last digit you have got same as one of the previous one, the next last digits are definitely going to repeat. So 3 power 6 is going to be 729, which is same as this 9. So 3 power 7, I don't know what it is. It will definitely have last number as 7. So here, how many different last digits you have? 4 different last digits we have. And what is the order of the last digits? 3, 9, 7, 1. Has everybody understood this concept, what I'm saying? Now we will not write for everything. So for number 4, 4 power 1 is 4. 4 square is 16. 4 cube is 64. See, I got a last digit which is already there, right? That's all. The next last 4 power 4 is 256. So if you check 4, 6, 4, 6 are repeating. So here there are only 2 different last digits. two unique last digits. What are they? Just 4 and 6. Has everybody understood this concept? So basically, we have to keep writing powers of a number. And when the last digit repeats, we need to stop there. Because whatever is there until that, the last digits, we're talking about only the last digits. This pattern is going to repeat. How many ever times you multiply, whatever is a power number. So any number that has base as 3 will have last digits as 3971 only. Nothing else you will get. Okay, 3 raised to any number, you will never get a number which is other than 3971. I'll tell you how to use it in estimating answers in some other topics. We'll discuss it later. Now, let us write last digits for all the numbers in a tabular form. Write down this. We will write last digits of all the numbers here. So here I'm writing the number. Here I'm writing the last digits that this numbers power numbers get. Okay. So what is the first one? If you have number 1, so I'll write all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, once you know the concept, if you have observed, we have not written those last digits list for all the numbers. We're going to write it directly here. Okay. So in a number ending with 1 will always have 1 as its last digit. And whatever we have discussed here, like number 3, if you are increasing its powers, the last digits will repeat in this cycle 3971. Now this holds good for all the numbers ending with 3, not just for the number ending with 3, not just for the number 3. For all the numbers ending with 3, this rule is applicable. So if you have 13 raised to some power, 23 raised to power, whatever, all these numbers will have last digits as either 3, 9, 7 or 1, nothing else. Okay, so number should end with this. So when I write number 1, it means number ending with 1. Okay, number ending with this digit and their corresponding last digits. Okay, please write down this. If a number is 1 or ending with 1, like 11, 21, 31, 121, whatever it is, if its number raised to different powers, all the numbers are going to have 1 as its last digit. Okay, then if a number is ending with 2, if a number is 2 or ending with 2, now how do you write its last digit? Just take 2 power 1. 2 power 1 is 2. Next is 2 power 4. Sorry, 2 power 2, which is 4. Next is 2 cube, that is 8. Next is 2 power 4, which is 16. I will write only the last digit, which is 6. Now 2 power 5 is 32, where the last digit is 2 and 2 is already written. So I'll stop here. Now we'll write the last digits for the next number. Now 3. 3 power 1 is 3. 3 squared is 9. 3 power 3 is 27. I will write only the last digit 7. 3 power 4 is 81, where last digit is 1. 3 power 5 is 243, where 3 is the last digit, which is already written here. So I'm not going to write it again. This is for 3. Next, we'll write for 4. For 4, 4 power 1 is 4. 4 square is 16, where last digit is 6. 4 cube is 64, where last digit is 4, and 4 I have already written, so I won't write it again. Now, number 5. Number 5 will always have 5 in the end. Only 5. 5 square is 25. 5 cube is 125. 5 power 4 is 625. So any number that ends with 5 will have 5 as the last digit. Next is number 6. If you have number 6, again, the last digit is going to be 6 only, because 6 power 1, we have written 6. 6 square is 36, where last digit is 6, and that's already written. 6 cube is 216. So last digit is always 6. And then we'll write number 7. For 7, 7 power 1 is 7. 7 square is 49, where last digit is 9. 7 cube is 49 into 7. What if it ends with 1? Because 0 power to anything is Sorry, 0 power to anything is 1. Any number power 0 is 1. We are not talking about, when I say number ends with, we're not talking about the answer. We're talking about the base number only. Understood? So 7 power 1 is 7. 7 square is 49. So the last digit is 9. 7 cube. What is 7 cube? You'll get 49 into 7, which is 350 minus 7 is 343, where last digit is 3. Okay. Now this number into 7, we don't need the answer. 7 threes are 21, 7 fours are 28. So something you will get, but the last digit is 1. Now this number, when you multiply with 7, last digit, you're going to get 7, which you have already written. Okay. So these are the 4 digits that comes as different last digits of 7. Next, we'll write 8. Now, what are the last digits of 8? 8 power 1 is 8. And 8 square is 16, where last digit is 6. 8 cube. So 16 into 8 is going to be 48, where you get 8 as the last digit. No. 8 squared, sorry, 8 squared is 64. Last digit is 4. 64 into 8. Okay, this is 8 cube, where last digit is 2. We don't need the complete answer. We just get 2. Now, whatever is this number, when I multiply with 8 again, 8 twos are, we get 16. This gets carry over. So the last digit is 6. Now, this number, when multiplied with 8, we get 8 6 are 48, which I have already written. So we'll stop for the numbers. So because it's going to repeat in this cycle, 8 4 2 6. Now for number 9, 9 power 1 is 9. 9 square is 81, where last digit is 1. 9 cube is 729, where again the last digit is 9. So we'll stop here. Now here, understand clearly. Number 1, number 5, and number 6. These have same last digits. Any number ending with 1, all its powers, the answer is going to be 1 only. Any number ending with 5, the answer will be 5. Any number ending with 6, last digit of the answer will be 6. This is for 1, 5, and 6. These 3 numbers have same last digit, whatever is a power. If the number is 4 and 9, if the number is 4 and 9, only for these 2 numbers, there are 2 different last digits. Okay. For 4, you have 4 and 6. For 9, you have 9 and 1. You don't have to memorize what are the last digits. You need to only know how many last digits are there. Hope it is clear. For all the remaining numbers, that is 2, 3, 7, and 9, 7 and 8. 2, 3, 7, and 8. For these 4 digits, the different last digits possible are 4. Is this clear? So what is the summary? So numbers ending with and number of different last digits. Number of different last digits. So if the number is ending with 1 or 5 or 6, number of different last digits is 1. There's only one different last digit, which is same. If the number is ending with 4 or 9, how many last digits we have? 2 last digits. For 4, we have 4 and 6. For 9, we have 9 and 1. Okay. For the remaining numbers, that is 2, 3, then 7, 8. For these 4 numbers, how many different last digits are there? 4 last digits are there. In this, for 2 and 8, you have even numbers as the last digits. For 3 and 7, you have odd numbers as the last digit. All of you have understood this summary? Now, when a number is given to you, when a question is given to you, what type of question do you get? Is find unit digit. Find unit digit in 23 power 56 into 21 power 13 into 46 power 12 into 32 power 28, something like this. This is a number that this is a question that you get, and you're supposed to find only the unit digit. Okay. Now, how are we going to use these concepts that we have learned here, the sum, whatever we have summarized, how are we going to use it to solve this question? So, you know, if a number is ending with 3, how many last digits it will have? 4 last digits. 4 different last digits are possible. And I have to guess what is the last digit of this one. And here 21 power 13, a number ending with 1 or a number ending with 1, whatever is a power, the last digit is 1 only, right? Which is itself. So here the last digit is 1. So there is a big number, last digit is 1. If a number is ending with 6, last digit is itself, right? So this is a big number ending with 6. Now I need to find out what is the last digit of 23 power 56 and 32 power 28. For this, we use this, you have to remember. Only this you need to memorize. You don't have to memorize what are the last digits, but you have to memorize this. For which all numbers you have one different last digit, for which all numbers you have two different last digits, and for how many numbers you have four different last digits. Okay. So here, if you have a number ending with 4 or 9, then it has only two last digits possible, isn't it? And understand how the pattern is. If it is 4 power 1, it is same as the number. If it is 4 square, then it is 6. Here, if 9 power 1, then same number you get. If it's 9 square, it is 1. Basically, if it's odd power, then same as the base you will get. If it is even power, you will get the other number. The other number you have to remember, 4 square, 9 square, last digit you have to remember. Is that clear? So before solving this, let us take only 21 power 13. Here, what is the last digit? 1. 46 power 12. What is the last digit? It is 1. We don't know what is the entire number, but we know the last digit is 1. Right? Now, if I have a number 24 power 13, okay, 24 power 13. Now the number is ending with 4. So there are two possible last digits, which are 4 and 6. Since the number is ending with 4, the last digit is going to be either 4 or 6. Okay. If it's 4 power 1, we get 4. If it's 4 square, we get 6. Again, 4 cube will get 4. 4 power 4 will get 6. So basically, if it's an odd power, I will get 4. If it's an even power, I will get 6. So here it is an odd power. So we get 4. Simple. If you have a number which is 19 power 28. Now this is 9. You know, 9 has two possible last digits, which is 9 and 1. Again, same thing. When you have two possible last digits, if it is odd power, you will get this first number, which is a base number itself. If it is even power, then you will get the other number. So here it is even power. So the last number is 1. All of you have understood so far? Here we have dealt with numbers that have same last digit, which is 1, 5, and 6. And we have seen how to find the last digit of the numbers ending with 4 and 9 because it has only two last digits. So if it's an even power, it's the same last digit. If it's an odd power, it's the other last digit. Now, if a number is ending with one of this, Samal has a question. Yes, please ask your question. So if the number is ending with 2, 3, 7, or 8, then it has 4 different last digits, right? Like our first number, 23 power 56. Here, you should know what is the last digit here. To find that, understand the pattern. This 2 power I have written, no? Understand this pattern. If the power is 1, 2, 3, 4, I am getting the last digits as 2, 4, 8, 6, right? Again for 5, 6, 7, 8. So for the increasing powers, the last digits are going to repeat in the cyclic pattern. Here, if the power, okay, if the power is a multiple of 4, 4, 8, For the next number, it's going to be 2 power 9, 2 power 10, 2 power 11, and 2 power 12. So if the power is a multiple of 4, then last digit is the last number. Okay, Samal, you can ask what is your question. I'm reading the comment, so please ask whatever is your question. Any number when you are dividing, so here you know that it is going to only repeat in cycles of 2486, 2486. So first, whatever is a power, divide it by 4. Why you have to divide it by 4? Because there are 4 different last digits. That's what I told you. You need to memorize only this. So for 2378, number of last digits are 4. Divide by number of last digits. Okay. So when you divide the power by number of last digit, here, let me take this as 18. Okay. If I take the power as 18. Now, when I divide 18 by 4, see what is the remainder. Remainder is 2, right? Remainder is 2 and quotient is 4. Means when I divide 18 by 4, 4 4s are 16. Remainder is 2. Just a second. So this is your quotient and this is the remainder. So what does this mean? You have 4 cycles of this number. Okay, this number repeats, it repeats in 4 cycles, and then there is 2 extra numbers. Okay, that is what the meaning of quotient and a remainder. Now this 4 is there. Now this remainder. So what does it mean? You have 4 cycles like this, right? This is 2 power 12. Then this is 2 power 16. Then you have 2 power 17 here, 2 power 18 here. You need to find how many cycles of 4 are done. After that, if your remainder is 1, means 4 cycles are done and it is the next number. If the remainder is 2, then it is the second number. If the remainder is 3, you get the third number. If the remainder is 0, it means the power was completely divisible by 4. Only then you get the remainder as 0. So if you get remainder as 0, then it is the 4th digit. Hope it is clear. So if the number is ending with 2, 3, 7 or 8, then power you divide by 4. See what is the remainder. That serial number of this last digits is what you have to take. So if you get, now see I have 23 power 18. I divide 18 by 4. I get remainder 2. Means second last digit I have to take. What is second last digit? This base number you have, no? For that itself you take power 2. 9 you get, no? That is the last digit. Understood? So what does it mean? If the number is 3, second last digit is 9. See, second last digit was 9, right? Suppose you have 512 to the power 23. Okay. Now what you have to do, base is ending with 2. You know there are 4 last digits. So 23, you divide by 4 and find a remainder of this. Okay. Remainder of 23 by 4 is 4 5s are 20. Remainder is 3. If it is 3, means you need to consider the third last digit in the last digits order of 2. For 2, what is the third last digit? For 2, third last digit is 8. It's not 2 power 3. It's just what last digit you get here. Okay. And how do you get that? Third last digit means 2 power 3 you can take, which whatever is the last digit you get for 2 power 3, which is 8, that is going to be the answer. It's a big number. Last digit is 8. Is this clear, everybody? Is it confusing? If you have a number 47 to the power 36. Now, this is number 7. Okay, 7 has 4 different last digits. So divide 36 by 4 and write down remainder. What is the remainder? 4 9s are 36. Remainder is 0. This is completely divisible by 4. Remainder is 0. If the remainder is 0, then you should take whatever is the last digit of 7 power 4, which is 1. Okay. 7 power 4 means last digit is 1. Now, the answer for this question, if you have understood all this, what we write is only the last digits. 23 power 56. 3 I will take, divide 3, for 3 has 4 different last digits. So 56 divided by 4, it will get completely divisible. Remainder is 0. Since the remainder is 0, I'm going to take the fourth, that is the last digit in 3's order, which is 3 power 4, which gives you 91. So last digit is 1. Next, 21 power 13. I'm not going to think because the last digit is 1 here. The answer will also have 1. 46 power 12. So if the base is 6, you know that any number ending with 6 will always have 6 in its last digit. Next, 32 power 28. Base is 2, which also has 4 last digits. So 28 you divide by 4. And what is the remainder? 4 6 are 24, remainder is 2. Since remainder is 2, this base you take this power. 2 power 2 is 4. So 4 is the last digit. Now 1 into 1, 6 into 4. 6 into 4 is 24. So the last digit is 4. Here, in the question, they will definitely not ask you the answer. You will be asked to find only the last digit. Is this clear, everybody? This is powers of a number, how you have to use. We'll solve, I'll post a video on some of the other questions, or if you have any questions, you can ask also now. And you can even ask later in the comment section. If you're watching this video later, then you can mention it in the comment section also. I'll reply. Any questions? Okay, so these questions you practice, and I'll share some more practice questions. You can practice them. In case you have any doubts, you can get it clarified. And as I have mentioned earlier in the group, today is the from tomorrow we'll have the paid classes also in Zoom. And any doubts if you have, you can get it very clearly clarified. And there are some of the complicated topics which it's very difficult to learn for you. For me, I can explain, but whether you have understood or not, whether if you have any confusions or clarifications, it's difficult to ask back. So such complicated questions, verbal comprehension, all that will be covered in the paid classes. So if you are a PGCET student, then join our paid classes, which is going to start from tomorrow. And these videos, see, if your likes and comments will definitely help us in reaching this video to reach many other students who are also preparing the same questions. So if you have understood these topics, make sure you like it, and also mention your feedback in the comments. Okay, see you all on Monday. These classes are on weekdays. So today is Friday. So next class will be on Monday. On Monday, we'll be starting with a fresh topic. And probably tomorrow, you will have a test for averages. So I'll mention it in the WhatsApp group. If you haven't yet gone through that, practice average questions, and you can take test for averages. And day after tomorrow, you will have a test for the next topic, whatever we have covered. Okay. Okay. See you all on Monday. Bye-bye.